I think it would be interesting also to know what folks think about how these missions relate to autonomy and like what we expect from a compute perspective to be necessary to actually perform these missions. For example, like
if we're looking for an ant, we'll detect a small set of pixels which seems to be moving.
Question of where to go, and without the audio tiling application, the where to go question did involve potentially a horizon-facing camera, which is pointed differently than a ground-facing camera.
Unless you have a camera that looks, 100 degrees, 120 degrees, it sees both the horizon and straight down, and that's it.
There's a number of commercial applications I'm familiar with involving listening for insects, because you can listen to a specific wing beat frequency, and then that way you can ID the type of insect. And this is actually very useful in agriculture, to know if you have pests and invasive insects. You can listen for the type of insect by their wing beat. So I don't know if the microphone could listen to the ants walking, if ants' footsteps make a signature.
The pitter-patter of little feet.
Yeah, pitter-patter of little...
Then would be a microphone on wheels.
A ears and eye cyclops on wheels in the wilderness with a cellular connection and a solar panel.
The Excalibur link is in the chat in StreamYard.
Thank you.
We're doing some mission planning session, right?
Yeah, so do you want to continue off from there? I was also, at least in my end, I was thinking about actually just running some MCAD modeling of the robot, kind of like in the background here, ambiently. And if somebody else wants to lead the kind of the mission planning system block diagram for final part selection, that could help inform the mechanical model. Like, for instance, if we need to have downward and forward facing cameras and these things.
Did we narrow down the mission last time? No, right?
No, we have 4 different missions. Potential missions. And maybe somebody has a better idea than any of these 4.
Are you trying to share something, Jasha?
Oh, yeah. Does it... So what I'll do, I'm just joining from my desktop as well, and I'll just screen share my desktop as well. But no need to present something, but in terms of just like productivity, I mean, does that make sense to kind of push along the MCAD model and somebody else leads the mission plan?
So we have to either choose one, right? We can't do both at the same time, can we?
Oh, yeah. I mean, I get it. I'm just saying, like, in terms of, like, I can just kind of model. I do this a lot, where I just am kind of modeling things in the background, like in the middle of a discussion.
Yeah.
I don't mean it to be the main presentation. Yeah.
Okay. Yeah.
Sorry, yeah.
Joshua, the computer is saying that unless you connect your mic to the desktop or something, we can't join you.
Yeah, so I wouldn't we wouldn't be able to share it on the screen or something.
Yeah, but it would be a screen share. Like that. Does that work?
Yes.
Wait, how does the backstage work? I see. So these are potential screen shares, and you can like kind of camera switch between them.
Yes.
Got
so now
it.
you have two things in the backstage. and there is one backstage screen share from my desktop.
I see.
So we can only have like one screen share at a time.
Got it. Well, yeah. So then, I mean, what I would suggest is I'll just live share the screen, and if it's relevant, we could show what I'm doing. Otherwise, we could just, because the core thing, we still have to find the mission, right? Like that's still the core challenge that will drive a lot of these things.
Yeah. So we had like 4 skeleton for the mission, right, last time. So we can choose one of them. Whichever is the easiest, I would say. Or does anybody have any other suggestion? So one was this plant inventory mission. This one.
The question I would have is there a least common denominator set of hardware that could be retroactively switch missions but have mission capability? So do we want to like build a platform that has universal mission capability out of what we've outlined? Or is there incentive to downscope for a particular mission at this time?
The moving platform would be the same for all of them, right? Or would
The
it
sensor
change?
payloads are different. Maybe that'd be a good activity. Yeah, to identify differences in the system between missions, if any.
Generic mission.
I think it would be interesting also to know what folks think about how these missions relate to autonomy and like what we expect from a compute perspective to be necessary to actually perform these missions. For example, like these things are like scan, target found, like moving to target. Is this target acquisition stuff like software, or what are we talking about here?
And does somebody who wants to lead the discussion about the system block diagram? I mean, would somebody be comfortable leading that discussion? I could certainly lead it. I just felt like I was kind of leading the discussion last week, and don't want to be overbearing.
No, if you like, yeah, it would be. If you want to lead, then just lead.
Okay. So right, I think you're asking about the software implications of these things. To build on the comment I had before is just we need to be concerned with feasibility right now on the software level. Like at the system level, we need to be concerned about feasibility. With that said, if there's just a certain amount of like, it just takes a little while to write the code, the main feasibility issue is the hardware, not the software. So we can always write firmware later is what I'm saying. But if there isn't enough compute to handle the workload that we're interested in at the hardware level, regardless of the software stack, then we're going to have issues. To my knowledge, there isn't a whole lot of open questions concerning the software stack besides like maybe image compression and where we would run an image compression workload. But this also comes back to the mission.
So like, but do we need to constantly stream the image? We could always have it on memory on the platform itself, right? And retrieve it later.
Yeah. I guess my main question would be, is there any difference to the hardware or the software stack for these missions that we've outlined fundamentally?
Yeah, I would want to know, like, do these missions require onboard image recognition?
No. In other words, we want to have software that can fit in a, M0 processor with, 2 megabytes or some other funny number. So we might have target-specific recognition. Like if we're looking for an ant, we'll detect a small set of pixels which seems to be moving, but not more than that. So we have target-specific recognition. But I think the answer to the question is, yeah, we have to see if any of the options require multiple cameras. I'm not sure they do. And if they don't, so we can say that the options don't affect the hardware design.
There definitely was with the plant identification. So if we look at the behavioral flow here, there's a question of where to go, and without the audio tiling application, the where to go question did involve potentially a horizon-facing camera, which is pointed differently than a ground-facing camera.
Unless you have a camera that looks, 100 degrees, 120 degrees, it sees both the horizon and straight down, and that's it. It doesn't have to be a 4K camera.
Is there a off-the-shelf 360 camera?
No. That's expensive. I just mean a wide view camera. Even 90 degrees might be enough.
Yeah, the off-the-shelf like Arduino cam stuff comes with different lenses, and one of them is like a fisheye.
Yeah,
Gives you a pretty wide degree. Which might be good for navigation, but might not be good for, I don't know, identifying objects.
So the camera that is pretty common and has a lot of software libraries behind it for these applications is the Omnivision. It's the OV2641. And so the OV2641, we could just put a different lens over the die at worst case, or you could get a wide angle version. And like as an example, this is just an Amazon link. That's the OV2640. Did I say 41? My goodness. The OV2640 that has just a really wide FOV camera glued on it. So
it already has it. The lens.
Yeah, this is all very off the shelf.
Yeah, and this is what I have on my first rover. Is based on that chip.
2710?
It's OV. I think it was 2710. Hold on, let me find it.
They list a lot of part numbers in that. That's a lot of different.
Okay, now it's in English. I was wondering why I'm not able to read it.
Yeah, so the reason why this camera is so popular is I think the 2640 has a SPI interface. Look.
How is this a stereo?
Here is a data sheet. I
think mine was the OV2640. So we were 2640.
The 2640 is the one that's like everywhere.
Yeah.
Everywhere. So that we can get anywhere, and it uses, actually, it's a serial camera control bus, which I don't know what that is. I think it's like a SPI bus, like.
It has, if I recall correctly, it actually needed 2 buses, one for like image data and one for like control, and it does all like image compression and everything on board. But I fought with the software quite a bit to get it to actually work properly on my platform, but it did work.
So the nice thing about like we're asking these questions, and there's all kinds of like tinkery makery posts. So like this image gives us the complete connections and pinout for the camera to the host MCU, which it looks like. Yep, there's a number of different pins. Yeah, so there's two. Yeah, so there's like a 2-wire interface, and then CSI. Yeah, so there's 2 buses. Oh, interesting. The camera also runs. It requires its own power supplies. It needs 2.8 volts and 1.2 volts. Okay.
No, not okay.
But the nice thing is it's like all here and we have the schematic and we can just copy and paste it in the flux kind of a thing.
But how are we going to provide 2 different voltages?
They have a part listed, so they have
the magic of electrical engineering.
I mean, without making the device too complex.
They have some weirdo power supplies that I have no idea who makes those. Like, if you look up that part number, what even is that?
Probably they are like voltage translators, these ones.
Yeah, they're bucks, but I'm saying it could be a fully integrated. It's a linear. It's just a linear. It's whatever.
It's probably an LDO.
It's just a cheap. Yeah, it's fine.
Sorry, what's the term you just used? I assume this is all like on board the like breakout boards that you buy off the shelf that it just handles that. Is that what we're talking about?
Yeah, what we're saying is we would put this in our system block diagram and then put it on our PCB, right?
Is that true for a camera? If like we care about like what would be the connection to like the the component that is actually the camera that is recording the pixels is probably going to be mounted or placed in a different direction than the PCB. So like what part is on the PCB side and what part is on the camera module side? Should we literally just take one of these pre-baked breakout boards and then run wires from it to our PCB?
God, no. So, no. The first link I posted in the chat, you'll notice there is a maybe 100 mm flex connector.
Mm-hmm.
And that gives you a lot of freedom to mount the camera in the mechanically desired place. So all we have to do is put a usually referred to as FFC, flexible flex cable connector on the PCB, and then we can just connect the camera to the PCB, and then it's flexible, right? So we can mount it above the board, below the board, right angle, at a weird 30-degree angle, wherever we need it to go. It makes it very easy to mount the camera. But if we're fabricating a PCB, the objective is most certainly to not be running wires, as it were. Like, do you have one in the ESP cams, Rhett? Like, it's the same setup. There's just a little latching FFC connector.
Yeah, it's just I have. I'll drop one I have. And so the problem is they're pins. It's like a header instead of a cable that latches.
Yeah,
but that's got tons. Like when I applied power to it, I think I just applied 3.7 volts, and it.
Oh wait, you're looking at a RD cam.
Yes.
Which is that's not just the image sensor.
Right.
That's what I mean.
Like, what part is going to live? You connect just to the image sensor, and then everything else to run that image sensor is on our PCB. Is I guess the design guidance.
Yeah, but okay. So this board that you're sharing, that's like a smart camera. So it has its own processor and everything going on. So that's like an assembly on its own.
Mhm.
What I'm talking about right now is just using the OV2640 like directly interacting with the lizard brain.
I see.
Which there, I mean, you could go either way. There are definitely going to be, I mean, there's design implications and cost implications either way. Like, how much is that RDCam?
I think it was like $40 or something.
Okay,
Yeah, that's a lot
that's
of
pretty
money.
expensive.
$26.
Oh, okay.
25, yeah.
Is that like a sourceable part though? Is that easy to get that one?
So the OV2640 is the camera part, and then there's this other chip, is what you're saying, is providing. It's like its own microcontroller.
Yes. Yeah. I mean, there's a that thing is doing a lot. There's a lot going on the RDCam. I mean, we could look for a schematic. Wait, I thought these were open source. Open hardware. Do they not publish a schematic?
Or they hide them? You know, I noticed that. I think we had talked previously about like Adafruit using their like open source designs to help out too, and they don't really make them super easy to find. Like you literally have to go to GitHub and find their through their org. You can find all their parts, but they don't link from their part to the repository, which I thought was interesting.
Oh, you got to look at the documentation wiki. But in general, yeah, you just gotta search the GitHub as well.
So yeah, RDCam has a org on GitHub, and let's see.
So I think just to explicitly state the trade-off that we're looking at right now, we can either use a camera sensor that there are open source drivers for, and the specific sensor in question would be the OmniVision OV2640. That's a sensor that there's a lot of libraries out there that we can directly interface with it from something like an Espressif ESP32S3 module. The other option is that alternative option that has a trade-off is to use an RDCam module that has its own onboard compute and then its own interface. So like we would be speaking with the RDCam, given the RDCam's like whatever API they have, versus directly interacting with the camera sensor. So there's definitely pros and cons either way. And I think the biggest question we should answer to help navigate that is how many cameras do we need? If we need multiple cameras, there are definitely system implications either way.
Are we going to do navigation with the camera?
I think we must, right? Or at least supplemental.
Not a lot of navigation. Again, the word navigation, we're going, from one spot to another. We're looking mainly at the ground. I agree we should be able to look all the way to the horizon. And we need some leeway because sometimes you're going downhill and sometimes you're going uphill. But it's not navigation as in we're on the floor of a room and we want to see what the walls look like.
So we are planning to have a GPS on board.
I think that GPS is not the GPS, the fisheye lens is good enough for the missions we have. I mean, let's look at the missions again and see if I'm right. But that's my feeling.
So you're proposing one fisheye, as in like 160 plus field of view.
Yep.
Pointed in which orientation relative to the robot body?
Pointed so that 30 degrees of the 190 are above the horizon.
Okay. And in terms of dealing
In fact,
with
it's too much. In other words, I'd be okay with 120 or 150.
and would the plan to have any compute workload on the robot? Or that's an open question to fire up the big brain versus send the image to the cloud and then have the cloud come in? Because there is an argument where it's actually like less energy to send the image to a server and have it think about what to do and then tell it what to do. But that's definitely an open question.
You know, it's strange. I think it depends how clever we are. Because if you look at the task of finding a plant and looking at it, then if we're able to write a plant identifier that can run on the M0, we do it locally. And if we're not, we can send it remotely. Now, I'm guessing, that in the desert, identifying a plant based on the fact that it's green, okay, or grayish, and maybe elongated is something we can do locally.
So basically, you could do basic object detection, because I've done it on what
Yeah,
was the processor? With an
that is what
ESPI. Yeah.
that's what I'm suggesting.
So basic object detection is possible.
I'm sorry, I'm still trying to determine if the ArduCam is open hardware.
Yeah, I'm browsing through their repositories. I don't quite see parts that way.
There are schematics.
Where?
I just searched for ArduCam schematics on Google, and there are multiple of them links. It's on the screen now.
I'm mostly just finding their software.
Can you link in the chat?
This is a specific version of it. This is an interesting one. Specifically made for TinyML.
Okay.
Yeah, but this is like an extra processor. We don't need it. We can do it with the same thing with an ESP32 we have already. We just need the camera.
But maybe we need the memory. Maybe we don't want to have interference with other processes we're doing. I'm not against having this, but Joshua indicated a few weeks ago that the more grains you have, the more difficult it is to program it and maintain it, and even to build it.
I am a little bit like, just experience tells me that although there's a certain convenience. So look, like there's no the Blues note card does a lot of stuff that will be annoying to bring up on our own. So this is also a module. So it's a similar question. It's like, if we're using the Blues Note card, should we just use the RDCam? And the advantage of the RDCam is it looks like it might have all of its hardware open source. Not completely. I still haven't found. Like, I know you found. So this schematic is not for the specific RDCam we're discussing. It's for a different product.
Yeah, it's called ArduCam Pico 4ML. So it's not like it's a one version of that ArduCam. But then, like when we are having multiple brains, then we have to think about our power budget, right?
Yes, it becomes much harder to control that aspect. And the system is more complex because there's more parts. And we have no idea how much power is consumed.
It says low power mode, 20 milliamps.
What?
Yeah,
It doesn't sound very low.
That doesn't sound that low.
It's terrible.
At normal, it's 70 milliamps.
Oh, okay.
Yeah, that's brutal.
And that's a 5 volts.
How much time does it take to wake up?
Yeah, that's a good question.
You know, if you turn it off, how much time does it take?
I
to
would
wake
imagine that I don't know I don't remember there being any specific instructions around low power mode. Maybe that just means like not taking a photo. Not capturing, which is like a thing you turn on capture or not capture. Oh wait, low power mode.
Where are you looking at it?
I'm looking at their documentation.
Okay, can you drop the link in the chat?
It's interesting. They on that board they use a different camera. It's monochrome.
Oh, the ArduCam, the Ardu chip is an ArduCam proprietary camera controller, which hides the complex camera, etc., behind a friendly SPI interface.
Yeah.
So that's the thing. That like, is that open source or not? And I'm betting it's not.
Well, so if it isn't clear that data sheet, this is the issue with camera sensors. Almost universally, they want you to sign an NDA to get a data sheet. And that makes that adds a lot of friction, a lot of friction. And sometimes, even if you're willing to sign the NDA to get the data sheet, they won't talk to you unless you're going to buy at minimum 100,000 to 1 million sensors. So that's part of why the cameras are a walled garden in a lot of ways. And so that's why I'm like, this particular 2640 is like a really old camera sensor, and there's this data sheet that's now floating around on the internet that makes it approachable, where a lot of these other cameras are not going to be. I think in this case, just to keep the design simpler and the parts easier to source, just use the camera directly.
Oh, the camera can be directly interfaced with the big brain, right? Or do we not want that? If you're not navigating it, then we just want to occasionally.
Yeah, I actually don't think that RPi can directly interact with the OV26440. I don't think it has enough GPIO.
No, but it has this RPi cam, right? It has some interface for it. So yeah, the RPi camera module. This directly goes onto the board.
Oh yeah, that goes right in. Yes, but is that the same sensor, or that was a different sensor?
You mean the camera sensor?
Yeah, like the Raspberry Pi camera. Yes, that's a specific thing, and they have a dedicated CSI header for it.
It's a Sony camera.
It's like an IMX 281 or whatever.
Yeah, it's 219
219
these days.
Yeah.
Yeah.
Yeah, exactly, these days. I also don't know if y'all have dealt with the RPI camera recently, but the driver stack is in the middle of moving between mainline. It's kind of a mess right now, in my experience, because they're migrating to lib camera, and lib camera wasn't necessarily, I think, in the mainline of Raspbian as of a few months ago. So yeah, like the RPI camera is currently a little bit annoying. So this is the thing. If we do want to use the OV2640, it's only going to be one camera per little host MCU, unless we mux multiple cameras, which could be a whole project on its own, or we could have multiple host MCUs, multiple lizard brains. So it's like
I much prefer, Joshua, if we feel we need two cameras, to make a piece of plastic prism that has two fields of views and projects them onto the same camera element. It's just adding
I think,
cameras sounds difficult.
yeah, I would agree for the first board, 100%. It reminds me. It was kind of funny. There was a company, it was called Double Robotics. They were like the first Segway style telepresence robot. I don't know if they're still around. Let me look. Yeah. If you just search Double Robotics, you'll see the Double 3.
I wanted one.
So the interesting thing about the Double is for I believe both Gen 1 and 2, they did not build the like display and stuff. It was literally an iPad, and they just used an iPad on a stick for the telepresence robot. The issue with that was, I don't know if you've ever driven a Double, but like one of the nice features of the Double is they have a downward facing camera. So if you're like stuck in a corner, you can navigate around whatever junk's on the floor. Thing about an iPad is it doesn't have a downward facing camera. So their hack for that was they had a little mirror in the iPad case that would pop up and point the camera onto the floor when you wanted to look down. And that was literally, they shipped a lot of robots like with that hardware to just have this clean system boundary between a stock iPad and then make it work for their robot application. As you can see, they've now finally built their own display with the cameras in the right place and all that, because I'm sure it was a huge headache to try to integrate with an iPad long term. But that was an interesting kind of like, because there's a lot of pull to use an iPad because it's like ultra robust, well understood, like very reliable. But then there's also a lot of long term downsides, which is like if it doesn't do exactly the thing that you want it to, it's a huge pain. But anyway, that's an interesting, relevant story. Yeah. So yeah, why don't we just do one camera with a wide FOV, and then when that doesn't work, do something else? We're making a camera with wheels. Isn't that it? That's kind of what this has come down to. We're making a camera, well, and a microphone.
Maybe it has a microphone.
Do we need to have the microphone? Or is that
It depends. If we want to do the soundscape, yes. We have several different options. So plant inventory, it's just looking at the plant. What's called here insect inventory. Again, you don't need a microphone.
Actually, you can. There's a number of commercial applications I'm familiar with involving listening for insects, because you can listen to a specific wing beat frequency, and then that way you can ID the type of insect. And this is actually very useful in agriculture, to know if you have pests and invasive insects. You can listen for the type of insect by their wing beat. So I don't know if the microphone could listen to the ants walking, if ants' footsteps make a signature.
The pitter patter of little feet.
Yeah, pitter patter, little ants. I bet you the leaf cutter ants, like the big ants, probably they have little shuffling sounds.
I'm sure that if you put a microphone 2 inches from the ground, you hear all sorts of sounds.
Mm.
But you want to be in the ultrasonic range.
How sensitive are these MEMS and mics?
I actually think the biggest issue with the microphone will be the wind buffeting, wind noise.
Yeah, so you put a foam, you put a foam cover on it.
Yeah, but it probably will just have to be like a thing we sample at night when there's no wind. Yeah, I mean, with regards to the sound stack, I don't have a pithy off-the-shelf approach to that. I think on our last call, we came across some really cool open source audio capture hardware, if I recall. Did that get linked or put in the Roam? I don't remember now.
Mm-hmm.
Does anybody remember what that was called? Because I brought up Rainforest Connection.
Yeah.
We found this like board, which is like the open sound devices or something.
Open audio or something, right?
Yeah. Is that it? Not it. Did we not put it in the chat? We must have put it in the chat.
It was in the private chat of, I think, the last recording.
So we can go looking in the recording?
Maybe.
Oh, is it a mistake to be posting in the recording chat?
Yeah, maybe, because it's not recording then. That's why I'm opening all the links so that I can get it back.
Oh, maybe
we can use Discord for this.
Yeah, but should we make a thread in the Discord for the weekly call to keep it not as cluttered?
Yeah, so we can do that. So I'll start a thread.
Cool. Yeah, and then we can repost. Because then I mean, not that Discord being searchable is a good grounding requirement, but it could be useful. Like right now. I straight up still can't find the thing.
Okay, let's see.
Sorry to distract, but I just realized that the newer version of the Ardu Cam is actually a much more like integrated component with a case and a wiring harness, and it's still like $26.
Yeah,
but the low power mode is like still 56 milliamps, and it's only a single SPI interface instead of like the dual bus thing, which makes it a lot less wires, which is kind of nice.
Yeah,
but it does just sort of have the benefit of like you don't have to worry about controlling the camera. It's a much easier interface.
Yeah, here it is. Audio Moth.
Audio Moth.
Yeah.
Yes.
That one.
That.
Okay, it's open acoustic devices.
Yeah, it's just not so cheap, but yeah.
Well, they have the schematic somewhere, right?
Yes. Where did I find it?
The data sheet.
It's on GitHub, maybe.
Yes, I see their GitHub is here. And then they have the firmware repo. I do not see the hardware. I think I remember this. I believe we came across this last week as well.
Yeah.
Because they have a nice data sheet, but then there's this like Gecko SoC they're using, and there's no hardware. Do we have the spreadsheet for the bill of materials? I feel like maybe we should capture some of this, because what would be a good activity that maybe somebody could handle. Like I could email them, or one of us, somebody could handle reaching out to AudioMoth and figuring out what their deal is with the schematic. Because if they have a schematic and this solves the microphone problem, that could be the minimum viable system right there. I would definitely on my end I would push for using something like the AudioMoth so that we didn't have to fire up the single board computer to record audio. I don't think that would be good.
That definitely makes sense.
Did we figure out if Rainforest Connection uses the AudioMoth or if it's their own hardware? What is this? Panorama.
Okay, here is the schematic and the bill of materials.
Oh wait, this is Circuit Hub. Wait, they have a Circuit Hub link?
Yeah. No, I found it on some forum. Somebody was asking some questions and they had the link there.
Oh, sweet. That's a great find.
Put it in the thread itself.
Yeah, we use Circuit Hub quite a bit for what it's worth. If you want to ask me questions about Circuit Hub, actually, just before this call, I was reworking boards that they messed up, but they're going to fix them. Circuit Hub makes a lot of mistakes in my experience, but I keep going back to them because they're always willing to fix their mistakes. And there are other board houses that are not.
So what is this site?
Circuit Hub? They're a prototype PCB fab.
Okay.
Yeah. So this is the build. This is the job for production. But they have kind of like you can share your design. It's a little bit similar to JLC PCB, but you can like share a link to your project and then fab the board.
Okay,
so this is like, you could actually fab this board. Yeah. Full turnkey. Like they have it quoted already, 700. So it's 150 per unit. Well, like,
but then so we can just download this and have it fab from somebody else, then, right?
Correct.
Yeah.
Correct. The issue, though, is this is not going to have the schematic. Unless... Did you download the assets and look? Because usually it's just going to be like the Gerber.
Because the fab doesn't actually need the schematic, right?
No.
Yeah, it just has the Gerber files. Download Gerber files.
One of the things that specifically is weird about Circuit Hub is they will take native ECAD files. So, and this has also bit me a couple times. They will take native Altium files and native Eagle and KiCad. They don't require Gerbers. Oh, yeah. If you download from that link, if you download the project, it has the Eagle board file.
Okay.
So we have the schematic. Okay. There it is.
So this then would be a microphone on wheels.
A ears and eye Cyclops on wheels. In the wilderness with a cellular connection and a solar panel. Which is interesting, isn't it? I think that'll be interesting. Won't it? If it just works.
Eyes and ears.
Eyes and ears. I haven't used Eagle in so long. I have it installed.
Where does Eagle fit in the ecosystem? I haven't heard of that.
Oh, Eagle is a EDA tool. It's for circuit board design. It was acquired by Autodesk maybe 6 years ago. And
is it
so
still
they
free?
Huh?
Is it still free? There is some free version of it, right?
I don't think so. Maybe. I don't know. Autodesk is like trying to make money now, and they're not doing a very good job, in my opinion. But I have to log in. I don't know. Here, I'm trying to open it. Like I don't know if it'll let me log in. And
I didn't actually explore this, but I noticed last time I was on Fusion 360 that it has some circuit design stuff into it, and so I wonder if it deals with Eagle files or if that's the technology they embedded.
No, it's the same thing. Yeah, they may have even rebranded it to just be. Oh, okay, so I logged in and it gave me an Eagle free license.
Oh, this is the microphone on board.
Okay. The schematic does in fact open an Eagle, and it appears to all be here. So we should be good to go to take an inventory of all of the actual parts now and complete the system block diagram. It would also be good to get that done because once we have the block diagram done, we can put the actual components into Flux and get the first bill of materials, and then we can see how bad the sourcing is. Because that could be a showstopper right there. Especially this design has some weird parts in it. So if we can't source the parts for the audio moth, then we might have to do something else. Yeah, for instance, the main processor on the audio moth looks to be unobtainium. Yeah, so this is that Silicon Labs Gecko. If you look at the Octo part, it is out of stock everywhere. Oh, we could buy it from WinSource. They're scalping. They're asking $90 for the chip that usually sells for $5. So yeah, this project is not going to be immune to the chip shortage. Here we are.
I thought the chip shortage was over.
No, not at all. No. Here, sorry, I'm going to rejoin. My phone's about to die.
Yeah, your audio is dropping.
Yes.
I actually have to drop off on time today, so I'm going to
Okay.
drop.
See you later, right?
Hey, Reg.
Sorry, what were you saying?
Is there a link for I can find the bill of materials that you guys referenced? I think it's on a Google Sheet somewhere.
Yeah. So I think Venkat had created some sort of Excel sheet. Are you talking about that or?
Yeah. It seems like that's like upstream of the block design, and sort of it seems like you guys are putting together for the block design.
So if you search like in what
So the Yakuza
Venkat's
system
name, yeah.
design. I think I've got the link. Just
Can you drop that into the same thread so that we get it back?
yes.
Is it the Yakasaur system design? That's the
Yes. That's the one I think.
okay. Thank you.
But is the like firmware open for this part? Then we can just replace this with something else.
Okay. Sorry, Niraj.
No, I was asking this audio mod firmware open source.
It might be hard to find, but thank you. Sure. Thanks. I'll drop off. Let's see you guys next week.
Yeah, so if that
Okay,
part
see
is
you
not
around.
available, then we could just port this to some other equivalent part. If this is the only thing that is going to some C files here. Okay, we are past the 1 hour mark. So let's stop for today, I guess.
Why not? Yes.
Yep.
Thank you for the component-driven session.
Yeah, I'll try to take these links and post it into the chat itself. Okay.
Thank you.
Cool.
Bye.
All right. Thank you.
Thank you, Joshua. Bye-bye. Thank you, Niraj.